Question 77, examine the two equations below. Where do they intersect? Now, my first thought is obviously, hey, I'm going to get some graph paper and graph these. One's got a y-intercept of 3, the other one has a y-intercept of negative 13, and I can see both of their slopes. But that's a pretty large graph, and I don't know that that's going to be the most accurate number as to where the lines would actually intersect. So what I'm going to use instead is substitution. I'm going to take this value of y in the first equation, and I'm going to substitute that in for y in the second equation, right? So I'm using substitution, and I'm going to rewrite this. These two equations are going to become 4x minus 3, that's the y from the first equation, equals 9x minus 13. Let's see it. I'm going to take away 4x from both sides, minus 4x. So I now have a negative 3 equals 5x minus 13. And I'm going to add 13 to both sides, adding 13. And 13, 14, 15, 16. So I get 16 is equal to 5x. That's what I thought. This would have been really, really difficult to see on a graph. It turns out that x is equal to 16 fifths. Okay, that sounds crazy, I know, but that's where x is at. What we need to do now is find out what the value of y is where this is occurring. So I'm going to take this value of x and I'm going to plug it into either equation above. I'm going to go ahead and choose to plug that into the first equation. So this is going to become, that first equation will become, let's see, y, that's what I'm trying to find, is equal to 4 times 16 fifths. And then minus the number 3. Well, I need 16 times 4, so let me do a bit of arithmetic. 16 times 4, 6 times 4 is the 24, and then 4, 5, 6, I have 64. So I have y is equal to 64 fifths, and I want to take this number negative 3 and I'm going to convert it into fifths. And I happen to know that that is exactly, let's see, 15. That's 15 fifths. And I know that because 15 divided by 5 is 3. So what I have here now is I got 64 minus 15 fifths. Okay, that's great. So 64 minus 15. More with the arithmetic here, right? 14 minus 5 is 9, and that would become a 5 minus 1 is 4. So I have 49 over the number 5. This would be a very, very difficult solution to find graphically. And I think that's why this question was asked here. We've been looking at these graphic solutions, and we always get the impression that, hey, make a graph and see where they meet. Well, that works. That would be hard to see. These numbers are not easy to identify. Anyways, my solution here is x is 16 fifths and y is 49 fifths. So that is where these two lines would meet with each other. You know, just on a whim, I decided that I wanted to graph these and show how cool Geogebra was at finding solutions for difficult problems like that. And I graphed them, and the first thing I'm noticing is like, oh my gosh, that looks like it's at 2, 5. In Geogebra, if you want to find where two things intersect, it's the intersect tool. So with that, you just click an object and then click a secondary object, and it'll tell you the point where they meet. So these lines are meeting at 2, 5, which all of a sudden makes my answer of 16 fifths and 49 fifths seem really embarrassing. So what the heck did I do wrong? So now, I mean, the big thing is like, okay, error analysis is huge, but where in the world is the mistake at? And probably some of you caught this when I did it, right? But if you look at it for a while, maybe pause the video too and see if you can spot it. Okay, so you've unpaused now and now you're listening again. So I hope you found it, but I finally found it, right? What happened was I added 13 to both sides, but you can see right here I've got a negative 3 plus 13, and I wrote down that that should be 16. And I was told from the time I was a very, very young child that if you combine the number negative 3 with a positive 13, what you should get is positive 10. So all of a sudden now this makes this question like way different. You know, all of a sudden it's just x is 2. And you know, I have to say I'm a little disappointed because I always feel like we're always coming up with these pretty answers, and I'm like, oh, that's cool, man. Look at that nasty answer. It was like 16 fifths and 49 fifths. That's a great answer. Well, actually, it's not that, right? Now that I know that x is actually just the number 2, I want to take that and plug it in here. So here's my 2 for x. So now I have 8. 4 times 2 is 8. And 8 minus 3 gives me that y has to be equal to 5. So my solution is 2 comma 5. And if I bring Geogebra back up here, I can see, yeah, sure enough, it's meeting right there at 2, 5. Hey, error analysis. I probably will post this video just because I like to keep it real and keep it honest.